This is a training video to demonstrate quick ground. It's also very similar for some of you Trimble users related to the here function where you would set up a base and a rover and you could just hit here. So it's very similar, although this tool allows you to accomplish a lot more things, and I'm going to demonstrate some of those. So we have a real project here where we have a subdivision lot number 31 that we want to survey. And we've identified some potentially existing property corners that we want to go out and find. And the objective is that we're going to take the one closest to the job site and we're going to use it to convert to the ground. So we went out and surveyed, and here's the lot number 31. We did find those existing corners. We specifically are interested in point 101 that we're going to use to convert to the ground, or you could use for here on a base and rover. So you will notice that when I surveyed, I did this in the Missouri Central NAD 83 with geoid 18. So you would want to use the state plane grid coordinate system as the base for us to convert to the ground. Here we are in Leica Captivate, and I have created a job called Quick Ground here. You will notice that the coordinate system is a state plane coordinate system, in this case Missouri Central NAD 83 with the geoid of 18. And I have went out and surveyed these points 101 to 104. And what we are interested in is 101, using it as sort of our here button and the point to create the ground coordinate system. So we would use our Quick Ground app, and you'll notice that it comes up with the coordinate system already. We hit OK, and it says, do you want to use that geoid model? You could use this or not. I'm going to go ahead and use it. I want to survey on the real elevations. And the scale method, I could enter this if I had a point nearby that I wanted to use, or there was sort of a county or citywide scale factor. But I'm going to use a known local point, 3D, and its coordinates are grid. And what I am going to do is, instead of type this in, I'm going to go get the point that I want, which is 101. It loads the coordinates, and I can hold the scale point coordinates, which is kind of nice because that is basically making the coordinate system start at that point. So the origin is at that point, and I like that because you're not scaling from the origin. And then I like to shift the ground coordinates so they don't look like state plane. Notice these are in the 1,400,000. So if I go down and I subtract 1 million and I subtract the 400,000, make sure we've got the right zeros. Looks like we do, 1,400,000. So what that does is that'll change these coordinates when we go to our ground system to not look like state plane. So let's go ahead and hit OK. And what we might want to name this is, we're just going to call this Quick Ground here. Notice it's actually doing a two-step transformation. So you could have done this using that kind of transformation. However, this was a lot easier to go about it this way. And then if we store it, ground coordinate system here has been created. And do we want to use it on the current job? Let's say yes. And so now, if we went and looked at our points, And we got to where we looked at the coordinates. Notice the million is gone and the 400,000 is gone as far as the northings and eastings. So we have a ground coordinate system created here. We just got through checking the coordinates, but let's take another look and see if we think we're on the right system. So we went to the properties of the job, to the coordinate system, and you'll notice that it's using the quick ground here coordinate system. You could switch back to the state plane coordinate system. However, what you want to do at this point is survey on the ground, so you're set to do that. You can also accomplish the quick ground functionality after you've surveyed. So I have brought the survey job into Leica Infinity. Notice we have the same points, and we're looking at point 101 as being our sort of here point. I am in Missouri State Plane Coordinate Systems. So if you'll go to Coordinate System Manager, and then go to Determine Transformation, we can give this a name, quick ground here. And instead of doing the classical 3D, we're going to use the quick ground method. Coordinate system needs to be state plane. Hit next. And now, instead of user entered for the defining the shift, we can use a known point. Again, that point is grid. And it's a little tricky to find it, but once you change to known point, you'll see the edit pencil here. And if you hit that, you can go choose the point. We're going to choose 101. Don't forget to hit OK. That populates the northern eastern ellipsoid height and is calculating a scale factor right here. Now again, we can hold scale coordinates. Right now it's not doing anything as far as changing coordinates. So we're going to hold them. Now that puts them again on the site, and I like to shift the coordinates so that these are not in the same coordinate values as the state plane. So we'll take the northing, that was in the 400,000, so we want to subtract 400,000. And in the false easting, we want to subtract 1,000,000. We're not going to shift the height, and you'll notice that we're shifting 400,000 over here and 1,000,000 here. So we've got the right setup, and all we have to do is hit create, and we can see the transformation calculation report if we would like, and that does verify your ground coordinate scale factor. So let's click finish, and there you go. It brings up the report, which can be helpful sometimes in finding how it decided to transform things. There's your scale factor right there. You'll notice that it shows up as a possible coordinate system. So we can close that. And then it's already changed the coordinate system to the quick ground, but if you need to go back and forth, you can do so right here. Otherwise, you really want to be surveying in the ground coordinate system.